Hi everyone. Today I am going to solve some of the questions of Punjab Assistant Professor exam which was held on 20th November 2021. So let us start. The first question was that the Poynting theorem is a mathematical statement of the conservation of what? The answer is electromagnetic energy. Then the next question was the ground state energy of the system of n interacting identical particles which are confined in a 1D box, and if the particles are bosons and the fermions, what will be the what will be the ground state energy. So if we talk about bosons, then we know that no Pauli's exclusion principle will be applied. So definitely all of the n particles will occupy the ground state, and we know that the ground state energy of the bosons is pi square h bar square 2 ml by 2 ml square, and adding up to n particles we get n pi square h bar square by 2 ml square. But for fermions we know that no like two there is a Pauli exclusion principle, so only two fermions with opposite spin can be occupied here in one level. So if I talk about the energy of the first fermion, then it will be pi square by 2 ml square into 1 square as it is in the ground state, and the same is with the other fermion. Now the third fermion and the fourth fermion will be occupying the first excited state. So adding up to so on n by 2 times. The n by 2 times is because the two the two fermions are already in one state. So like in if you see the options, there are two options which are uh, looking like the same, but if you clearly see the summation sign, then A option will be the correct one rather than B. So okay, the next question is electron in a hydrogen atom is an eigenstate 1 by 2 minus 1 by 2, and uh, of the operator sz. So if we want to find out the expectation value of sx or sy, then it will be 0. But if it would be sz, then it will be mlh cross, msh cross. Ms is plus minus half, so if they ask mz expectation value, then the answer would be C. But if they have asked sx, or even if in question it is sy, then the answer would be 0. Next thing is Hermitian operator of del by del x. So it is also one of the straightforward answer, minus del by del x, because if we do the dagger of d by dx, then upon solving we get minus del by del x. Then another question, in the next question here they have asked that x component of position and y component of momentum. Now we know that from Heisenberg uncertainty principle, delta x delta px would be greater than or equal to h cut by 2 or h cut. But if they have asked delta x and delta py, or even if they ask delta x delta pz, like if the coordinates are different, then there we can simultaneously find out the position and the momentum, so no uncertainty will be there. So delta x delta py will be 0. So option C is the correct one. Next question is in 1D harmonic oscillator, there is a perturbation of a x cube. Then they have asked the first order correction to energy in ground state. So in harmonic oscillator, this is my actually this pic is from my notes, so I have already solved this question. um, uh, if they have asked about the uh, uh, the perturbation, then you can clearly see that if we have the odd powers of x like x cube, x5, x7, or even in momentum, then we know that expectation value in harmonic oscillator, it is 0. So it is a direct question that if you have odd powers of perturbation given in the question, then the answer would be 0. No correction in ground state will be there. Then the next question is also very simple, that we have been given the wave function. We have to find out the normalization constant. So simply what we have to do, as we know, we do the squares of the coefficients and compare it with equal to 1, because the square of the coefficients gives us the probability of finding that very particular state. So if we do the calculation, the value of normalization constant comes out to be under root 6 by 5. So B will be the correct option. Then in this question, they have given a trial wave function, and by variational method, you have to find out the ground state energy of hydrogen atom. So again, I am pasting this picture from my notes. Actually, these are Viru sir notes from Quanta Institute. He has beautifully delivered the quantum mechanics lectures. So they are available on YouTube. So I have just solved this question for variational principle. What we do, we firstly find out the normalization constant, and from the normalization constant we find out okay, firstly we found out the normalization constant, then we find out the kinetic energy, as you can see, and then we find out the potential energy, adding the both, as you can see. Then we find out the Hamiltonian by adding the both, and with what we do is we do the derivative of the Hamiltonian with respect to the parameter a is, or alpha is in this case. So after solving all, we get the answer as ground state energy is equals to minus me4 2 times 4 pi epsilon naught h cut the square. 4 pi epsilon naught, actually in this question they have considered it as 1. In usually questions they consider it as 1, or maybe in some other units they have converted. So if I see the options, here are the options. So you can see, obviously B option is incorrect, because plus cannot be the ground state energy, as it is a bound state. So in bound state we always have negative energies. Now looking at the other options, me square will not be the correct answer, because if you remember the ground state energy of the usual ground state energy which we solve by Schrodinger equation and all, so me4 comes out. So option A and D could be the correct answer, but on solving, if you see, then option A would be the correct answer on solving. So the next question, okay, this question is not complete actually. They have asked, like, if you have particles, fermions, classical particles and bosons, then what you have to find out is to order of pressure. Actually we know it is a kind of direct result. We solve this type of problems in StatMech, but usually it is advised to remember this result, that for classical particles the pressure is nkt by v, and for Bose-Einstein or boson particle, it will be the minus of the classical pressure, so it will be lesser than the classical one. And for Fermi-Dirac, some terms are added, so fermions will have more pressure than the classical and then the bosons. So option C would be the correct answer. Then in next question, it is given that we have given the Miller indices of the planes. We have to find out the order of sorry, not order, but the ratio of the interplanar spacing. So for simple cubic we know that DHKL is equals to A by under root of h square plus k square plus l square, where h, k, l are the Miller indices. So simply just putting the values, we get this. So on solving, option A would be the correct option. Then in next question, if an ensemble is stationary, what would be the condition? So I think that the Hamiltonian is time independent, and density function would be a function of Hamiltonian only. So option D would be the correct answer. In next question, a crystalline solid is given, and in ground state what would be the entropy? So I think it is the third law of thermodynamics. So option A would be the correct option. Entropy is zero in ground state. So the next question is that n distinguishable particles are restricted to move in a plane. So if they are restricted to move in a plane, we have two-dimensional thing. So dimensionality of phase space. So we know that for n particles, we have 3n dimensions of position and 3n coordinates of momentum. So but if we have two-dimensional particles, so what we have, the coordinates we have are x, p, x, y, px, py. For n particles, what it would be? 4n. So the dimensionality of the phase space is 4n, option A. Then in next question, the number density of free fermion gas in 3D has been increased 8 times. So what will be the variation on Fermi temperature? Then we know that Fermi energy is proportional to the number density raised to power s by d, where s is equals to 2 for electron. Actually s here for photons is 1, for phonons it is 1, for magnon it is 1, not for magnon it is 2. So like these are the values of s. And for dimension, we have been given 3D gas, so d is equals to 3, putting the values. Now we know that Fermi temperature is equals to EF by kb, where kb is the Boltzmann constant. So clearly Fermi temperature is also proportional to n raised to power 2 by 3. Now we know the number density has been increased 8 times. So what happens is that Fermi temperature, but just plugging the values, the Fermi temperature will be increased 4 times. So option A will be the correct one. Then we have been given indistinguishable particles in thermal equilibrium at temperature T. We have non-degenerate energy states with energy 0, 2e and 4e. Sorry, here would be 4e, not 3e. I have written wrong in the diagram. So now they are asking average energy per particle. So let us solve. Uh, Firstly, find out the partition functions. We know that partition function is must to solve such kind of problems. So if we find the partition function for n particles, then it would be 1 plus e raised to power minus 2 beta e plus e the power minus 4 beta e, where beta is equals to 1 by kt. So the average energy of these n particles is given by minus d by d beta log of qn, natural log of qn. So if we solve, we get this one. So if beta is less than beta e is less than 1, then average energy is given by this expression. Now in question we have to find out average energy per particle. So divided it by n, we get this result. So the option B is the correct one, that is 2e. So next question is, a sample of silicon has electron and hole mobilities as 0.13 and 0.05 at 300 Kelvin, and it was doped with phosphorus and aluminum with doping densities of 1.5 into 10 raised to power 21 and 2.5 into 10 raised to power minus 21, sorry, not minus 21, plus 21 again. The conductivity of doped silicon would be, Then it is one of the previous year questions of net in electronics. So if we find out the resulting doped crystal, then there are more number of p type impurities than n type impurity. So the resulting dopant would be 1 into 10 raised to power 21 per meter cube. So conductivity is given by this formula. So as they have just approximated the result, so as n type n carriers are less as compared to the p1, so they have just put the values and option A is the correct one. Then next question is output of logic is 1 when all inputs are 0, then the gate is either. So in this case, just like what I have used is that in OR gate or AND gate, when outputs are 0, inputs are 0, output is always 0. So just check the option that OR gate and like OR gate is now all the three options. So definitely A, C and D are not the correct option. So B is by default the right answer. So even you can check also, B is the right answer. Then in semiconductor, in next question, semiconductor diode barrier potential offers opposition to only. So the answer is majority carriers in both the junctions. And the next question, led, the principle of led, actually it works on the basis of recombination of electrons and hole. So D is the right option. Then the color of bright spot on the screen of CRO is a characteristic of. So the answer is coating material of display screen. So D is the right answer.